Hello everyone. In this video, we will see how and what is linear regression in short. So, linear regression has two words, linear regression. Linear is nothing but a line, just a straight line. And regression is the strength and character relation between dependent variable and independent variable. So it's very simple that dependent variable is going to be our prediction. For example, if we want to predict the price of a house, so price is going to be our dependent, and independent variable is going to be the size. In simple linear regression, that is one predictor variable and one independent variable. So we know that the equation of linear regression is y is equal to mx plus c. So as we know, y is our dependent and x is our independent variable. Now the question is, what is m and c? C is our constant, so which is also known as intercept, and m is the slope. Let's see what is m and what is c by plotting the equation. Let's assume we have to predict the house price using its size. So we are going to predict the price. Here y is going to be our price and x is going to be our size. Now these are the data points. Let's plot it, x-axis, y-axis, and we are going to draw a line where more number of data points are touching. So this is going to be our y is equal to mx plus c. Y, x, m and c. Just by drawing it, we will be able to identify what is going to be our next prediction. For an example, if there is a new data point with this size, we can easily predict what is going to be its price. So we have this as our size. So corresponding will be the price of that particular size house in future. So this is how we are going to predict for each and every new data point. Let's jump and check what is C and what is M now. So whenever we draw a straight line, that is linear line, so wherever the point touches over here, this is nothing but the intercept, which is C. And next we have to know what is M. Let's consider this data point over here and this data point over here. Let's consider this as 100 and this as 200. The difference between these two, what is going to be the unit change in the measure of the data points, is going to give us the slope. This is going to be our slope. Just as an example, if x is equal to 0, let's consider x. So we know y is equal to mx plus c. If x is equal to 0, what happens to this equation? Y is equal to c. As x becomes 0, m slope also becomes 0. We don't have any x, so y is equal to c. This is going to be our data point. Next, let's find out, before going to that, what could be the change if x changes and how y changes. That is what we are going to identify using m, that is slope. Next we are going to see how to find the best line. So best line, we know there are so many data points and we can easily draw as many lines as possible, but we want to know how to find out the best line. To find the best line, we have to minimize the error. So what is error? Error is nothing but, let's consider E as error. We actually predicted minus actual, so is going to be our error. So y hat minus y, prediction minus actual, this is going to be error. But we need to minimize the error between the slope of the lines. to know that we have a cost function. Cost function is defined as summation of all these errors. So it should be the minimum summation of the error, so we could find out the cost. Best fitted line. This is nothing but mean squared error. 1 by 2m summation of all the lines predicted minus actual, the square. So here MSE is nothing but mean squared error. And we have MAE. A stand for absolute. Instead of taking square, we are taking the absolute. Why we are taking square here and why we are taking an absolute value over here is because if there is any negative value, by squaring we can take that to a positive, and by using modulus we can avoid the negative values. So it is to avoid the negative values. For that we are using this cost function. This is it for this video. Let's discuss in depth how the cost function is working and how we can identify the best cost function using gradient descent in the upcoming videos. Thank you.